Certain hygroscopic material change properties depend on the measured content, which depend on the humidity. Human air, some animal membranes, and certain plastic show a dimensional change in response to humidity. If a sample of air is cooled at constant pressure to a temperature called the dew point temperature, the moisture in the air will start to condense. This temperature plus the initial temperature can be used to determine the amount of vapor in the air. Psychrometric device. If the bulb of the temperature measuring an air temperature is surrounded with a wick weighted with water, it will measure a temperature lower than the true air temperature. The lower temperature is known as wet bulb temperature, and another temperature is known as dry bulb temperature. The temperature of the wet bulb is dependent on several heat transfer processes. The sought-after effect is convective heat and mass transfer between the wet wick and the surrounding air. Unfortunately, there is also conduction heat transfer along the steam and radiation heat transfer to the surroundings. If the air velocity relative to the wick is on the order of 5 milliseconds, it has been observed that the wet bulb temperature will be very close to a temperature called the adiabatic saturation temperature. This air velocity is achieved with the sling psychrometer by causing the housing to swing around the handles in a circular motion. It should be noted that the adiabatic saturation temperature is not the same as the dew point temperature. The dry bulb temperature can be used together with the adiabatic saturation temperature to determine the air humidity. A convenient way to do this is to use a graph called a psychrometric chart. So that is the end of chapter 7. For more examples for chapter 5 and chapter 7 will be discussed this week. Please go through chapter 5 and chapter 7 video before lab 2 session this week. Thank you very much.